In a centrifuge, you have a bowl and scroll that create a differential speed between them to move solids through the centrifuge. In this video, there are several items to look at as far as the cross-section of the machine and the internals as well as the regulation. On the right-hand side, we show a graph that shows pressure as well as differential speed. And there are several buttons that are parameter set points that control the automatic regulation of solids movement through the centrifuge. The centrifuge has water and dirty liquid coming in, clean liquid coming out, and solids being separated due to centrifugal force in the chamber between the bowl and the scroll, as it's shown here with only water in it at this time. As the machine video starts, there will be solids added to this mix, and the solids will be brought out through the conical section of the machine to the solids discharge opening on the left, and the liquid will carry out on the liquid end to the right-hand side into the housing and overflow. The automatic regulation of the centrifuge is important to keep the solids loading of the machine constant. In order for it to function properly, the solids loading has to be consistent, where about 2/3 of the centrifuge are filled with solids, but the right-hand side, the last third, will be clarification area where the particles settle, and on the left-hand side, you have the dewatering area where the solids are being pushed up this cone and exit the centrifuge. The automatic regulation works similar to the cruise control in your car. When you're going up a hill, it kicks in more gas to maintain the speed. When it's going downhill, it lets off and it will reduce the gas or the power to maintain the speed downhill. Here, this automatic regulation will increase the differential when the pressure is high, and it will decrease the differential when the pressure is low. And that's how it keeps the solids loading the same. On these buttons, the first button is a set point for base speed. Delta N, here it's set at 2.0. 2.0 means a differential speed of 2. That means solids that are here at one flight in 1 minute will be 2 flights or 2 revolutions over to the left. This is typical about 8 to 10 inches per flight, so 16 to 20 inches travel through the centrifuge when at a differential speed of 2. P1 is the start of regulation. It is not a pressure set point, but it's the point at which pressure it starts regulating itself. For every increase in pressure, there's an increase of differential speed here. The white line represents the base speed of 2. The blue line represents the P1 or start of regulation, and the black line is the actual trajectory of where the differential speed is in relation to the pressure on the left. The higher the pressure, the more differential is needed. The more solids are in the machine, the higher the pressure will be. As I start this video, you will see solid particles getting into the machine and settling in the space between the bowl and scroll. As the solids are being moved out, the centrifuge will speed up once it reaches this P1, and you will see the actual pressure here on the bottom right increase, and you will see the actual differential speed increase once it hits the P1 set point or exceeds the pressure past 100 bar. Now still at 2 differential speed consistent, and the bar pressure starting because there's more resistance because the solids particles are entering the space between the bowl and scroll. The more solids are here, the higher the bar pressure will climb. You can see the differential speed still at 2 RPM. But now, as it goes past 100 bar, you'll see more solids being pushed up this cone area to the solids. The water will stop coming out the solid end and is now pushed to the liquid end by the dam that the solids form. We're at 120 bar, and we're 1 RPM over the original because the third button, alpha, will adjust how much the differential speed goes up. 20 means 20 bar per RPM. For each 20 bars increase, you will get another RPM on top of the base speed. Right now we're at 4.3 RPM and 147 bar. You see solids on top here carrying over into the liquid end. And to prevent this, it keeps speeding up right now at a 4.5 and 150 bar. It's found its equilibrium, and the solids loading is kept constant on this machine. Here you still see the pressure and the differential speed shown. This will find its equilibrium at this level, and then if there's more solids going in, it will increase the differential even more. If there's less solids, it will reduce the differential to keep the solids loading constant and to make sure the centrifuge functions properly. The solids have to be moved out at the same rate that they're entering the machine. If they're entering the machine faster than they're being carried out, the solids will carry out and make the liquid dirty. If the solids are being moved out too fast, then there's not enough seal here and not enough solid stem in order to keep the liquid on the right-hand side. The solids loading has to be kept constant, and the proper setting of these parameters will achieve this.